We will start. So welcome to this lab. In this we will be discussing what is CCS, use of CCS simulator, and how CCS can be used to generate a sine wave. So this is, in this lab we will be using TMS 3206713 DSP kit. This is what is the figure of this DSP kit, and this DSP kit is of Texas Instruments. This is connected to computer through which we do programming, right? So Code Composer Studio is the integrated development environment for TI DSP. So to program this Texas Instrument DSP kits, we cannot do directly, and a DSP processor understands only the machine language 011. So to write a program, we use Code Composer Studio. This is, in fact, provides the interface to the user or the developer and the DSP kits to write an algorithm which can be ported into DSP kit. So we can write a program either using C language or assembly language. This Code Composer Studio can support both C language as well as assembly language. But writing program using assembly language is advantageous from one point of view, because the codes written in ALP will be small, optimum, runs faster. But other way, disadvantage is the writing ALP code is difficult, because we have to understand each and every instruction, which is really a difficult task. So take care of that. Code Composer Studio provides another feature in which we can write code using C. So what this will do, the user will find, first of all, the user will find out the algorithm. After finding the algorithm, he will write the code in C. C code will be converted to assembly code. The assembly code will be converted to machine language and will be loaded into the DSP kit. After that, the DSP kit will start working. This is what is the function of Code Composer Studio. Now DSP kits, the Texas Instruments DSP kits, or any DSP kit is capable of doing the real-time operations. So to test whether the algorithm which we have written is correct or not, we have to connect the DSP processor, which is always not feasible. So take care of that. Code Composer Studio provides a simulation environment. In this simulation environment, we can write a C program or ALP program and simulate without connecting DSP kit, and test either the algorithm what we have written is correct or not. So for that purpose, we will be using Code Composer Studio simulator environment. So for this Code Composer Studio simulation environment, we will be discussing, our research scholar Apurva will be telling us how to create a sine wave using this Code Composer Studio. But before that, we'll just slightly understand what is the DSP kit environment. Let us say this is what is a TMS 3206713 processors, in which we have this is my processor, and To this processor we give input through this. Analog input we will be giving through this. To this processor, the inputs given are whatever given, it is converted to in the form of samples. So what is done in a DSP processor, as we have understood in class, the processor will process the samples sample by sample. So one sample has reached, it will do the processing. That means whatever the algorithm we have written, that algorithm will be processed. That algorithm will be computing the output using one sample. Once that sample is processed, its output will be available. And next wait for getting the next sample. So how the DSP processor will understand next sample has arrived. That is why we use the interrupt signal in a DSP processor. So whenever a next sample will be available, the interrupt will be interrupting. Then after this interrupt is available, a set of signal processing algorithms or a set of subroutine will be run to get me the output. Okay, that is why to run a whatever algorithms we have written in, so we have to include few files. One is the C file, .c file, which is the source file where we have written the algorithm. Next is the .cmd file, in which it will be indicating where our memory, because this is a processor will have memories, RAMs will have memory locations. So this .cmd file will indicate where my program will be written, will indicate where my results will be stored. So that .cmd file will have certain specific things written which will indicate where these things will be done. Then there is a .leaf file which provides a mechanism by which whenever it provides a place when the interrupt subroutine will start. So this file also we have to include while starting the DSP, while starting this C code, simulation of the C code. Along with that, we have to add one more ASM file. What is the use of this ASM file? That you can explore further. And when we will use these things and then build the program, we will be able to get a assembly language code which we can run. The same thing, whatever we discussed now will be explained by Apurva, our research assistant, on CCS simulator directly for generation of sinusoidal signal. So now we can move to that system.
So insert the disk. Wait for a minute. We have to install products. We have to install C6000 Code Composer Studio version 3.1. So we will get only two menus icon on the desktop. Then go to the main menu and exit, and then we will get two menu icon. One is the CCS Studio 3.1 and another one is the setup CCS Studio version 3.5. We have to double click on setup CCS Studio v3.1. Before starting the CCS Studio, we have to select the platform. We have worked with two platforms. One is the simulator and another one is the DSK board. So here I will discuss only the simulator. So double click on setup CCS Studio v3.1. I have already added the C673 device cycle accurate simulator. So first I am removing this C6713 device cycle accurate simulator. Remove board, yes. Then we have to select, because we want to work with simulator, so we have to select C6713 device cycle accurate simulator, and then we have to add it. After adding this, it will be added in the My Systems window. So we have to click on this TMS 320 6713 and right click on, go to the properties, and select the detected reserve memory access no. Because if we want to adjust the memory properties, we have to select the detect reserve memory access is no. So okay, and then save and quit. So it will ask start Code Composer Studio, yes, then start, yes. So CCS is open, maximize it, and then if we want to, here C6713 device cycle accurate simulator window is open. So now we want to create a new project. So we have to go to add a new project. Go to the project, add new project file, enter a new project name, any name, like I'm going to explain sine wave generation. So enter the project name is sine. You can change your location. So here we make a new folder on desktop. Its name is sine. Then we can change our location. Location name is sine. Okay. So this is our location. Project type is executable, and target, you have to make sure the target is TMS 320 C673, because this is the 6713 family name. Then finish it. After finishing, sine.project is open. Then expanded it, and then creating a new project. After creating the new project, we have to create new source code. So for making a new source code, we have to go to the file and select new source file. Source file name is untitled one. It's a default name. We can change name like any. This is mainly a C window file, file name. So we can save this file as a select Ctrl+S, or go to the file and select save as. So here we will select sine folder, and file name should be same. Is a untitled one is a sine. Extension should be .c, because it's a C file. So .c. Save. After saving, we have to add this file into this project. So right click on it, add files to project, then sine.c file is open. So we have to write our C code. So C code is any C code for sine wave generation. This is the sine code, sine wave generation code. And then again then save it this file by using Ctrl+S. Then creating a project, after creating the source code, we have to include some libraries file given by the Texas. So again we go to the project directory window and add files to the project. We will go to the desktop, my computer, then local disk C, and select CCS Studio V3 version 3.1. These are all the C6000 family. So first select C6000. Then CZ Tools is the Texas Instrument wave generation tool. So select CZ tool. Here file of type is all files name, all files, and select live file. Library file, it's a runtime support library file, RTS6700. Click on open, then add it. So RTS6700.live file. Another one is two files. One is the .cmd file, is a linker command file, and .asm file is a vector interrupt file. So we have to include all these files. So again go to the add files to the project. Again go to the desktop, select my computer, local disk C, CCS Studio. Here we have to select tutorial and the DSK6713 family, DSK6713, and hello1 is the file path name. So if we want to select .cmd file, then choose linker command file is a .cmd file. So file name is already by default file name hello. So select hello and click on open. And another or last library file, last vector interrupt file is add files to the project, add vectors. Vector is .a file, it's a assembler file, vectors, then click on open. So all the files are included here. After including all the files, writing the codes, again save it by using Ctrl+S. So so the code is now be built and start for running. So first click on rebuild all. It is showing 0 errors, 1 warning or 0 remarks. It means code is correct, all the functions are correct, so error is 0 errors. After building all the things, we have to load the program. How to load the program? Go on file and load program, click on load program. So already, click on debug. Inside the debug, one out file is generated, sign.out file. So select sign.out, click on open and open it. It's automatically run all the files. It's a assembly files, and after loading the program, we have to run this program. How to run it? By using, go on debug toolbar, select debug and run. After running the program, the code is correct, so all the things are correct. Error is 0, 1 warning and 0 remarks. After debugging, we want to plot the graph. For plotting the graph, go on view. For plotting, select graph, time and frequency. Here display type is single time. All the things, single time, dual time, FFT magnitude, and all the things are already given. Graph title is graphical display. Start address is name of the address. Here address name is A. So or address of array is same thing. So type A. Acquisition buffer size is 128 is the size of the start address. Display data size, it depends upon you. If you want to change this data size, you can change. Display data size is the size of this array. DSP data type is mainly two types, fixed point and floating point. Here DSP data type we want to select 32-bit IEEE floating point because it's a sine wave generation. So select 32-bit IEEE floating point. And DC value is 0, cursor mode is data cursor, and then click on OK. So one time refresh it, and this is your sine wave generation by using simulator. If you want to change color on all the things, you have to select, go on option and select color of the editor color and tools color. Is the color of the editor windows as well as your toolbar color. So this is the simple sine wave generation by using CCS Studio. If you want single time F50, so select F50 magnitude. Okay, this is the F50 graph. And then if you want to see the memory location of all the sine wave values, we have to select memory, go on view, select memory. Here address is your memory address is A. Name of the address name is A or anything is the output of your code. So address is A. Format is here 32-bit floating points. That's why we select 32-bit floating point and OK. These are all the sine wave values. And if you want to add one thing, this is your sine C. If you want to see this A values, so add to watch window. Watch window is used for seeing changing. If any change is present in your variable, then you can see it here. These are all the sine waves values. This is called watch window. You can watch all the variables simultaneously. And this is your build option. If error is present or not, it's showing error or it's not. Depends upon your code. And this is the simple sine wave generation using simulator.
Any error will be there? How can you know?
Sir, if any error is there, it means if we remove, then one error. So if you want to remove this error, so code is, it means not correct. So check in your code is correct or not. Here one error is present, so code is not correct. So first correct your code, right here, code correct, it means include global variable, again Control S and then run. Zero error, it means code is now correct. So this is the simple sine wave generation using.
Based on this, you can do the lab experiment.
Based on this, you can do your lab experiment. Like linear convolution, circular convolution, and ramp signal generation, square wave generation by using by using simulator, not using DSK. Sir, thank you.